and arrive at a specific point to the nearest second, all whilst traveling at 10 kilometers per second. If Voyager missed this point, or was a few seconds off, it would have ruined the gravity assist and its following gravity assist around Saturn. In order to achieve such incredible accuracy, Voyager had to know its exact location in space and control its speed with great precision. 5 sets of thrusters placed around the space probe would allow Voyager to rotate around all 3 of its axes. This was super important since its large antenna had to be constantly facing Earth in order to send and receive signals. These thrusters would fire tiny millisecond pulses, rotating Voyager at around 0.3 degrees a second. At this rate, it would take an entire 5 minutes just to turn 90 degrees. Then there was another set of identical thrusters that could be fired for longer durations to alter Voyager's speed, allowing NASA to finally control its trajectory over time. But how did Voyager actually know where it was and where it was going? Located on Voyager's antenna was a device called a sun sensor. It detected the sun as the brightest object in space and commanded Voyager to rotate until it locked onto it. This would correctly align the X and Y axes and ensure that Voyager's antenna was facing Earth. In order to sort out the roll axis, a star tracker facing 90 degrees away from the sun sensor would look for a specific star which had a known level of brightness. Again, Voyager would rotate around this axis until it locked onto this star. But Voyager couldn't always rely on these systems. Anytime Voyager passed by a planet, its sun sensor would be temporarily blocked. Likewise, when Voyager rotated to take pictures of specific targets, both sensors would no longer be facing their reference points. And so, to keep track of how much Voyager had rotated, it had an onboard gyroscope, which could be used for several hours at a time.